Okay, Kyttaro Therapeutics is a company with a platform technology on genetically modified mesenchymal stem cells. And one of these cells we have is a cell that's producing Klotho. I show you a short video which explains almost everything, and after that I will go more into detail.
Are revolutionizing anti-aging therapy by producing Klotho, a protein that fights aging at its core. Klotho protects against age-related diseases like heart disease, diabetes, and neurodegeneration. Imagine increasing your health span, the time you live free from illness. MSCs that produce Klotho could be the key to maintaining vitality as we age. Investing in this technology means supporting a future where longevity and a better quality of life are within reach. This isn't just science. It's a breakthrough in how we think about aging, and the time to act is now.
So, well, for the one of you who do not know what stem cells are, stem cells are a special type of cells derived from the mesenchyma with special features. They adhere to plastic, they have certain markers on the surface or miss certain markers, and they can develop in the adipocytes, osteoblasts, and chondrocytes. Klotho was detected by Kuro and his colleagues in 1997. It's a gene disrupted in a certain mouse strain which inherits symptoms resembling human aging. And they named this gene after the Greek goddess Klotho, who is spinning the thread of life. Mice who are Klotho deficient, they usually die within 90 days. They stop growing at the age of 3 to 4 weeks, and they show almost all signs of human aging. Klotho mainly is produced in the brain or in the kidneys. This explains also why it works in these special diseases pretty good. And there was a publication, a review 2 years ago, showing in which diseases Klotho plays a major role. And these are mainly diseases related with aging, like neurodegenerative diseases, tumors, chronic kidney disease, pulmonary disease, and heart disease. This is our data. And I will explain you later why we went into oligodendrocytes. What we did is we used the Klotho produced from our mesenchymal stem cells and cultured oligodendrocytes. Oligodendrocytes is a special type of cell. They create a sheet around the nerves and are necessary for exchange of messages between the cells. And we could show that Klotho increases the number of major oligodendrocytes. When you get sick, your oligodendrocytes die off and the precursors start growing, and Klotho goes more into these adult cells. And it also increases the messenger RNA for two proteins which are on the cell surface of oligodendrocytes. Here's the proof of concept. We got these mice from Kuro from Japan and established the bread. And we injected to the Klotho deficient mice 1 × 10⁷ MSCs Klotho with the human Klotho. And all the mice with the MSCs Klotho survived. We stopped the experiment at 180 days. And the mice that received saline, they all died within 100 days. So this is the proof of concept that our MSCs work in a preclinical model. So what is about aging? There are these hallmarks of aging. They are changing because there is a lot of research going on. But here in this publication from 2022, they showed these 10 hallmarks of aging, like cellular senescence, stem cell exhaustion, autophagy, epigenetic alterations, genomic instability, and so on. And when you go into the literature, 8 out of these 10 hallmarks of aging, there's a research data that they are addressed by Klotho. And Klotho is doing this by inhibiting TGF-beta pathways, NF-kappa B pathways, NRF2 pathway, EGF1 pathway, WNT pathway, and promoting autophagy. So there's a bunch of literature from researchers that show that Klotho is helping in these pathways. What are stem cells doing? Stem cells produce exosomes or extravesicular vesicles, and in these extravesicular vesicles you find proteins, RNA, and all the stuff, which is a good stuff for anti-aging. They enhance angiogenesis, they reduce inflammation, they regulate proliferation, apoptosis, so all the features you see in aging. So what are the preclinical data from other groups for MSCs and Klotho? In this group, they have shown when you give old mice young MSCs, they will survive longer. If you give them old MSCs, they also will survive longer, but not to the same extent. So it's very important, even if the surface markers are the same from old MSCs and young MSCs, you have to use young MSCs. That's why we use Wharton's jelly or umbilical cord MSCs for our product. And another group has shown when they inject a gene, a vector that produces the cloto in an aging mouse, that the mice live longer. And more in male than in human, in female mice. It's the same like in humans. Female mice live anyway longer than male mice, so the effect is not as pronounced as it is in males. So for us, it's more important to get cloto than for the women. What are the clinical data on stem cells and cloto? The clinical data, there is already one clinical study with patients who already suffer from frailty. They injected 100 million cells for one time, and even 180 days later, the patients who got the MSCs had an improved 6-minute walking test, had improved lung function with the FEV1, and had a reduced TNF-alpha, so reduced inflammation. And what about cloto? The NHANES is the abbreviation for National Health and Nutrition Examination Survey. This is done in the United States since about 50 years. Every year they take in between 10 and 20,000 patients, draw blood from them, and all the data about their health, about their lifestyle. And since 3 years, people go back and look what happened with people who were examined at the early 20s, what happened with them in the next 20 years. And they could show in more than 100 publications that there is a strong correlation between the cloto level they had 20 years ago and then that they developed either aging diseases, inflammation, neurodegenerative diseases, chronic vascular diseases, diabetes, kidney disease, or even that they died earlier. One of these papers was done in more than 9,500 patients with already frailty, and they could show that there is a linear correlation between the cloto level and the score of frailty. What is our goal? Our goal is we want to use this MSC's cloto like a Trojan horse. We inject it into the patient, and this MSC's cloto will as well produce the cloto, who works on these pathways, and will produce the extravesicular vesicles from the mesenchymal stem cells, because we have shown that by introducing this new gene, this does not change the intrinsic property of mesenchymal stem cells. They behave like naive mesenchymal stem cells. And all this together, we believe, has a strong impact on longevity, health span, and lifespan. We know that cloto decreases with age, and we believe, or we are sure, our MSC's cloto will stop this decrease, and thereby helping to avoid a lot of diseases and to increase health and lifespan. What do we have? We have the genetically modified cells. We have the patent granted in Europe, pending in the United States and Canada. We have all SOPs established, and we have the preclinical data, so we have the preclinical proof of concept. What do we have to do? Of course, you cannot inject a human being MSC's cloto and then wait for 30 years to see if they develop Alzheimer's disease or cancer or die earlier. So you need to address it in a disease where MSC's cloto may work as well. And this disease might be amyotrophic lateral sclerosis. We have to establish GMP production, we have to do a clinical phase 1 study, and then we have to do a clinical study in these patients. Why amyotrophic lateral sclerosis? This disease came into attention to the public in 2014 with the Ice Bucket Challenge. It's a disease that affects around 5,000 patients in the United States per year. The number of patients is increasing worldwide, and it's a devastating disease. Patients die within 3 to 5 years after they are diagnosed with ALS, and there's no cure so far. So why do we believe that MSC's cloto work? In this review paper a year ago, the group from Milan showed that oligodendrocytes are the major cell that causes amyotrophic lateral sclerosis. And these cells get destroyed, and MSC's cloto will restore the oligodendrocytes. And in the clinic, there are already data with MSCs. In this study, they gave 67 patients 30 times 10 to the 6 MSCs every 2 months. And what they could show, they could prolong the average life from 640 days to 1,183 days, and they could lower the score of the disease. So it's clinically proven that MSCs could work in ALS, and a lot of research data point to that cloto will help to better work with the oligodendrocytes. So in summary, genetically modifies MSCs that produce Klotho, leverage the natural anti-aging properties of Klotho and the regenerative capacity of MSCs. They offer a dual mechanism to extend health span. They can treat a variety of age-related conditions. There are much more, which I could not show within this 10 minutes. And they hold the promise for developing innovative therapies. So that's it, and we are open for anyone who wants to partner with us. Thank you very much.
Marcus, thank you. That was great. Thank you.